So let's go ahead and start with the word system. If you see the word system in math, what it's going to mean is that there are two or more. If I say I have a system of equations, what that means is I have two or more equations. System of equations means two or more equations. That's what that means. There is also something called a system of inequalities, which would mean two or more inequalities. Just so you know what that word means. Systems means that you got more than one. Okay? Second thing we're going to write down is the word solution. When we write down the word solution, I'm going to be asking you to find a solution. A solution is a point that is on both lines. A point that is on both lines. Now, if we're writing down a point, you should know that a solution, since it's a point that's on both lines, should be some x comma y. It would look like this. For example, I'll put example here with a dot. For example, x comma y. That could be a solution. It's some x, some y that we could graph. The answer should always be an ordered pair. An ordered pair. An x and a comma y. It's where the two lines intersect. I'm going to put that down. This is my last thing. It's where the lines intersect. Where the lines intersect. What we're going to have to do is going to seem like a review from last unit. Like what we did last unit, we start off doing the very first section in Chapter 4, Unit 4, deals with graphing. So if you understood graphing in Chapter 3 or Unit 3, you're going to do just fine in Unit 4 at the very beginning. For example, this is like number 4. Y equals x plus 3. Y equals negative 4x minus 2. Let me make sure you can see those negatives. Y equals x plus 3. Y equals negative 4x minus 2. Your directions will say something along the lines of solve each system by graphing, check your solution. That's what it's going to say. So that's what we're going to learn how to do. When we have to do this, it is extremely important to be as accurate as you possibly can. So when I draw this, I'm actually going to draw mine with a ruler because I want to be as accurate as I possibly can. Feel free to try as best you can to draw straight lines as much as accurate as possible. I'm going to go 1, 2, 3 that way. I'm going to go 1, 2, 3, 4 this way. I'm going to go 1, 2, 3, 4 that way. And each time I do it, I am going to put numbers next to there. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3. Negative 1, negative 2, and I'm going to try to be equally spaced apart. Just try to be accurate. The hardest part about solving by graphing is if you are off just a little bit, you may not be able to find the correct solution. So what you're going to have to do I'm going to zoom in a little bit on this so you can see. We're going to graph both of these lines. So I'm going to take this top equation. I'm going to graph it in blue because I have a blue pen right now. And I'm hoping we know what the y-intercept is of this problem. Mark, do you know what it is? No. Okay, let's see. Rachel, do you know what the y-intercept is? Good. Mark, what is the y-intercept? No. Rachel just told you. Rachel, would you tell us what the y-intercept is again? Perfect. Mark, what is the y-intercept? Perfect. That's what I wanted to hear. It is a positive 3 because that's in y equals mx plus b mode. So that is what we graph first, the b. From here, I go which way? Left, right, up, or down? Class, can you say it out loud? Perfect. 1, 2, 3. Here's my dot. From there, I have to use the slope. The slope is the number in front of the x. There's no number in front of the x. It's an invisible 1 over 1. If you don't see a number in front, how many x's do I have? I have 1x. That's why there's an invisible 1 in front. Don't think of it as nothing because there is 1x there. So from here I go up 1 over 1, and because I like to be accurate, I'll go up 1 over 1 a couple times. And I'm going to take my ruler and I'm going to be as accurate as I possibly can. As accurate as you can. Try to go through the exact center of those points. Try to use the graph paper that is on there to do this accurately. Otherwise, you might get the wrong answer. Now I did that one in blue. I'm going to do the bottom one in red. And the first thing I have to go to is the y-intercept again. Because Mark had issues with that the first time, I'm going to give him a chance to redeem himself. Mark, what is the y-intercept for the red equation? Perfect. Good job. Which means we go as a class down 2 spots. From here, I have a slope, but it's negative. Down 4, to the right 1. 1, 2, I have to add 2 more lines. 3, 4, and over 1. At this point, this is how come you want to be accurate. Let me just show you. If I go like from this dot to this dot, I don't know if that's going to be the answer, but I'm going to try to line everything up because my answer is where these 2 lines intersect. A solution is where the 2 systems cross. Where are they the same? They are the same right here, right where I'm pointing. My answer should be an ordered pair. Some x, some y. Do you know what that x is? Do you know what that y should be? What is the x?
-1.
And what's the y?
2.
And depending on how you graphed it, like that's how come. If you went like this just a little bit, you might think that it might be a different number depending on how you graphed. So make sure your lines are as straight as you possibly can. Otherwise, you may find a different solution. And what we can do once we get our answer, because this is the answer that we think it is, we can check to see if it's the right answer. Let's check the blue equation. Okay, here's the blue equation. Y equals x plus 3. I can plug in -1, and I could see, does it equal 2? When I plug in this for my x and this for my y, does that work? Does -1 plus 3 equal 2?
Yes.
That means this point is on that line. Now I can do the same thing with this second equation, the red equation. Y equals -4x minus 2. I can plug in the -1 there, and I could see, does it work? Negative 4 times negative 1 is a positive 4. Minus 2. Does that equal 2? Does this solution work for both equations? That's because it's on both lines. That's where they are equal to each other. That's our answer. Okay? So that's how most of our problems are going to be. Most of our problems are going to look like that. But we have to go down another road on the other side. That's how the front half of your worksheet is going to be. Okay? Like the first 6 questions are going to be very similar to that. You'll have to answer some word problems, which aren't too bad because they describe some things. But on the back side, you have to tell one solution. Let me scoot that up a little bit. Infinitely many solutions or no solution. This says one solution, infinitely many solutions, or no solutions. This is what your directions literally say on the back side of your worksheet. What I want you to think of is that when you see this title, one solution, infinitely many solutions, or no solutions, you need to think these are possible trick questions. The front side, there are no trick questions. You're all going to get an answer. You're going to get things that have one solution, just like we did right here. This means there's only one solution where the two lines intersect. It's only one place, right? That place, right there. But sometimes there might be something like this. There's these two other possibilities that might happen. Let me show you what infinitely many solutions look like. Well, one solution looks like. Let's do that first. If there's one solution, then one line will intersect another line, and it doesn't matter where, but there's one solution where the blue line and the red line intersect. Infinitely many solutions, on the other hand, sometimes you're going to get something where you have one line and then a second line is right on top of the other line. The blue line and the red line are on top of each other. I know this is a little mature for some of you, but these two lines need to get a room because they're all over each other in public, and that's just a little too on my part. Okay? All right. Super inappropriate lines here. Gosh. There's infinitely many solutions because this point works for both lines. This point works for both lines. This point works for both lines. There's an infinite number of points that work for both lines. This means that the two lines are the same. Lastly, no solutions look like this. If you have a line and another line is parallel to it, one solution looks like that. Infinitely many solutions, they're the same line. And then no solutions, the lines are parallel. Does this red line ever touch or intersect the blue line? No. It's like a sad love story where this line looks across and sees another line that's going in the same direction as it, but they will never cross paths. So sad. It's a tragedy. That is it. That is all. That's all my jokes for today. I don't got any more. I got nothing left. I got nothing left. Okay? No, wait. No. Meaning, I have no more bad jokes. Because I know I'm losing you on the bad joke thing. Okay? Okay, it's all good. No more bad jokes. If they're parallel and have different y-intercepts, parallel, different y-intercepts, it is no solution. There's a symbol for no solution if you want. It looks like this. You can use this if you would like for no solution. Infinitely many solutions, there's a symbol for that. Looks like this. These have same slope, and same y-intercept. Just so you are aware, those are the trick questions. I'm going to stop your notes right